All right. So last class we learned law of sines. There is something called the ambiguous case, and it happens when angle, side, side, when we're given those three. And in order to understand why there may be two different triangles, we're going to go back to geometry and talk about why side-side angle did not work. So I'm going to play this short video first.
So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have two sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how.
So pausing right here for just a second. Notice these are 2 different triangles. I don't know if I can write on top of a video. So, oh no. That was triangle 1. And this could be triangle 2. It could be possible that there are 2 triangles depending on what you're given.
Choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side side, however, the base of each triangle clearly are not the same, and these triangles clearly are not congruent. So due to this...
Alright. If I can get that to stop. Okay. So 2 triangles are possible. That's not the case every single time, but it is possible. So that's what we're going to start with. The steps are the same. So we're going to solve the triangle if possible. Then we're going to do 180 minus the first angle found. And then if we can, add the given angle. So just like before, I'll have A, B, and C, and little a, little b, little c. Alright, and I know that big A is 123, little a is 47, little c is 23. That means the first thing I'm going to find is big C. So, sine C over 23 equals sine 123 degrees over 47. Cross multiply, divide. I'm doing this part rather fast because it is under the assumption you've already practiced the actual solving for sine, like using law of sines to solve for the sides and angles. So in my calculator, I would put sine inverse of 23 sine 123 over 47 equals C. So I would get that C equals 24.23 degrees. Again, I would type that in my calculator. I'm just looking at an answer sheet. All right. Actually, let's just round that to 24 degrees. All right. To find angle B, 180 minus 123 minus 24 means that angle B would have to be 33 degrees. And then I would solve for little b. by doing sine 123 over 47 equals sine 33 over b. I'm going to go ahead and skip those steps. If you need to pause here, by all means, pause here, solve for yourself, and see that you also get 30.3. Okay. All right. Now, here's how I see if there's a second triangle. What was the very first thing I found? So this is why, like, organization matters. What did you find first? This is what I found first. Okay. So I am going to do, so here's how I test for second triangle. 180 minus 24. That means that my second, if I had a second triangle, then my other C would be 156 degrees. Okay, here's my problem with that. I was given the 123. So here's 123. Here's 156. This is what I like to say busts. What that means is that 156 plus the 123 is greater than 180 degrees. Why does that matter? Because if it's greater than 180 degrees, it busts. It cannot be, when I say bust, I'm kind of thinking of like if you've ever played blackjack, you know, if you go over 21, it's called busts. And so if it busts, it cannot be possible. So there is only one triangle for this example, hence one solution. Let's look at one where two triangles are possible. So again, I only have to test this theory when I have angle side side. So if you have to draw yourself a triangle and label that this is 35, A is 12, B is 16. So that's angle side side. So I know that A is 35 degrees. I know that little a is 12 and then 16. Okay. First thing I'm going to do is solve for B. So sine B over 16 equals sine 35 over 12. I need to go through the same steps that I went through in this first one, but to shorten the video here, so press pause if you need to, see if you get that B equals 50 degrees. Okay. So you have the choice here. You can go ahead and solve the entire triangle so that you're done, and then do step 2, which is test the 180. I like to test the 180 right here so that I don't forget what I solved for first, because sometimes we get to work and we forget what we did first. So I know that B is 150. If I do 180 minus 50, I get 130 degrees. So what happens if all my givens still are there? So we can't change what the problem gave us. It gave us that A was 12, it gave us that B was 16, and it gave us that big A was 35 degrees. But I can change my B to be 130 degrees. If I do that, does this bust? So I need to test, does this bust? So 35 plus 135, 35 plus 130 is 165. Notice that that is less than 180. So a second triangle is okay. To find that third angle, I would just subtract, right? And get 15 degrees. Whereas if I go back up here, I do 180 minus 35 minus 50. and get 95 degrees. So now I have two little c's to solve for, and I would do that the same way that I did my entire last assignment. So sine big A, whoops, let's not put A because we know that A is 35 over 12 equals sine 95 over C. Skipped a couple of steps there, so if you need to pause and try it yourself, go right ahead. I do go over how to solve these step by step slower in the previous video of law of sines, so if you have not watched that or need to watch it again, please go back. All right, so let's see, C is 20.8 in this one. That makes sense because the biggest angle should be the biggest side. Whereas if we do it with our other one, so sine 35 over 12 equals sine of 15 over C. We're going to get that little c equals about 5.4 if I round. And that makes sense because the smallest angle should have the smallest side. So that's how I find out if there are two triangles. Got a lot more work to do there with two triangles. Okay. It is possible to have no solution. So this one actually goes very quick. So I have that A is 50. Little a is 10. I don't know big B, but I know little b is 20. And I do sine 50 over 10 equals sine B over 20. All right, so I will go ahead and take the time to cross multiply, divide, and then inverse. So what I would type in my calculator would be this. But let's take a second to think this through. 20 divided by 10 is the same thing as just 2, right? So 2 sine 50. Sine 50 is going to give us some type of decimal, and we're going to double it. What that's going to do is make sine greater than 1. And if you remember that, so this part right here will end up being greater than 1. If you remember, I can never find a sine inverse of a number greater than 1, and it has to do with graphing. So think about where the max was. The max was at 1, the minimum was at -1. So therefore it will not work. For those of you that are like, whoa, you just blew my mind. Let's go back to what we had originally. Okay. We can just type that in our calculator, no big deal. Probably need scientific. And then, so 20, oh, we need to do sine inverse. And then 20 sine, I don't even remember what it was, 50. And then divided by 10. You'll get undefined in the calculator. So if you get undefined in the calculator, that's really all you need to know. That means that it cannot happen. So it is not a possible triangle. And that would be your ambiguous case with the 3 different types of solutions. We will be practicing more in class.